to that count you observed already in the table. So that count of individual atoms, left side and right side, individually they are same or not, that you can observe here. See here, 1 1, 2 2 and 2 2. So individual atoms, left side, reactant side and product side, both are same, no difference in the count. Then we'll go for the one more equation here, that is simply the reaction between the metal and the activity number 2, metal sulfate, sodium sulfate and barium chloride, giving you two substances. One is liquid and another is white colored powder separated at the bottom of liquid. So two substances, one is barium sulfate and other is sodium chloride. Sir, it is very difficult, sir, remembering. No problem, easy here. See here, these two combination and these two combination. So easy, Na and Cl, NaCl, BaSO4, BaSO4. Okay, that crisscross method what you learned in 9th class. Okay, using that we can write simply that compounds formed. Now look at here, count the individual atoms. Count the individual atoms, making a table. See here, which atoms we found in that? One is sodium, sulfur 2, oxygen 3, barium 4 and chlorine is 5. 5 different atoms. One more adding, so totally became 6. 6 number of rows, 1 2 3 4 5 6 number of rows we are taken. Then 3 columns, 6 by 3 table. So here the first one is about atom, next one is number of reactants and number of products, that are atoms individually. Okay, number of atoms in reactants and number of atoms in products. So atoms first, sodium, next sulfur, next oxygen, next barium, finally chlorine. Counting on LHS side. So left side, sodium subscript is 2, so we can write 2. Sulfur, no subscript and no bracket. Observe both, no subscript, no bracket, so 1. Oxygen, subscript is there but no bracket, so here 4. Next barium, no subscript, no bracket, 1. Chlorine, no bracket but subscript is there, 2. Next right side, first sodium, here sodium in the NaCl, no subscript, no bracket, 1. Next sulfur in BaSO4, no subscript, no bracket, 1. Next oxygen in barium sulfate, so BaSO4, 4. Next barium in BaSO4, 1. Next finally chlorine in NaCl, 1. So now look at the count, are the same as you observed in the first example? Use your quick impression, yes or no? Yes or no? Yes, no. Are the same in the second? No. There is difference in the first example and the second example. First example and second example, difference is there. So here, according to that, are these two said to be same equations or different kind of equations? Different kind. Then we will go for one more example here. Look at that equation. Third activity, Zn, zinc metal piece added to the hydrochloric acid and giving you one is liquid remains in the conical flask and the gas is liberated. So two products are there. That liquid remained in that beaker is ZnCl2 and the gas is evolved is H2. Gas is evolved is H2. So this is the equation. Tell me number of rows and columns in the table. Anyone? Number of rows and number of columns. Use number. You don't have option to unmute. Use the numbers available in the reactions. How many rows? How many columns? Rows by columns. Rows by columns. Suppose 2 by 2, 3 by 2, like that. First one is number of rows. Next one is columns. Tell me. Or raise your hand. I will unmute. Yes, Shivani responded. 4. right? So here 4 are rows. What about columns? What about columns? Mohit, 3, right? So here number of rows and columns are here 3, 4 and 3. T Sanjay given. Okay. So now here table ready. So number of rows 4, 1, 2, 3, 4. Number of columns 1, 2, 3. So as many eyes you counted here. Look at counting of that individual atoms. 1, 2, and 3. Only 3 are available. So that we can take eyes here table. So very easy to write down. The next here, write the titles in the first one. Atom, number of atoms in reactants, and number of atoms in products. Individually atom names, Zn, H, and Cl. Right? Zn, H, and Cl. No need to verify that atoms on right side. Directly you will get that right side, same atoms repeated. No new elements are produced in any equation. Remember that. So only left side or right side observing the individual atoms is enough. Then writing them. Count. Zinc. Here no subscript, no bracket, no coefficient. So only 1. Then what about hydrogen? No subscript, no coefficient, 1. Chlorine, no subscript, no coefficient, 1. So the counts are given as here 1, 1, and 1. Then go RHS side. Here Zn, no subscript, no coefficient. So it is given as 1. Next hydrogen, there is subscript 2. Next chlorine, there is subscript 2. So what I got? 1, 2, 2. Count is 1, 2, 2. Now observe the 3 tables at a time. Observe the 3 tables at a time. What do you find? Your observations are the same? Are the same in the count? No, not same. They are not same. So here simply based on that, if both sides in mathematical equations, both sides that is same, what we can say, that is equation as balanced equation. That is given as balanced equation. So here in this chemical equations also it follow the same, right? So here the first one is same, called as balanced chemical equation. Second one not same. The third one also not same. They are given as unbalanced chemical equations. Got my point? Identifying the type of equations as balanced and unbalanced chemical equations. Go to your quick impression. Is it clear, everyone? How to verify the given equation is balanced or unbalanced equation? Very easy one. Very easy one. Yes, very good. So I know that equation is balanced or unbalanced equation. Then next we will go for another topic is about sorry, just a second. Right. Now the screen is visible. Just we missed the screen. Right. So now here simply the next topic is about the same thing, types of chemical equations only, but balanced chemical equations definition. How to define a balanced chemical equation? Can anybody raise your hand to define the balanced chemical equation, please? Anyone? As I given you example. As I given you example using the tables. Raise your hand. Yes, someone raised a Medashri. Yeah, first Medashri. Okay. Unmute yourself.
Sir, if the number of atoms in the reactant site and product sets are equal, then it is called as balanced equation.
Divina, unbalanced. Divina, unbalanced. Unmute yourself, given you chance.
The number of atoms difference in the elements.
Where? In any equation, if the number of atoms of different elements or atoms, number of atoms of different atoms on left side means reactant side, on right side means product side. If the same, that is said to be balanced chemical equation. Look at that. If the number of atoms of different atoms or elements on left side and right side, left side means reactant side, right side means product side, same, called balanced equation. See here, highlighted, same, balanced. What? Count is same. Where? Left side, right side. Which count? Atoms count. Simple. Right? So we can define that easily. For example, here carbon plus oxygen useless to carbon dioxide. This is example for the balanced chemical equation. See the count. Carbon, left side 1, right side 1. Oxygen, here subscript is 2, right side, oxygen, subscript is 2. Balanced. So this is example for the balanced chemical equation. So now, definition of unbalanced chemical equation. Here they're same, different. What different? Count. Whose count? Elements count. LHS side, RHS side. So if the count, the number of atoms of different atoms on left side and right side of an equation are not same, then it is called unbalanced chemical equation, also known as skeletal equation. Also known as skeletal equation. This balanced chemical equation has another name. Also, it is called as stoichiometric equation. Stoichiometric equation. Remember, balanced chemical equation also called as stoichiometric equation, unbalanced chemical equation also called as skeletal equation. So what the equation you are written directly with the equation is called primary equation. That primary equation may be sometimes balanced equation or maybe unbalanced equation. For example, here two examples on the screen. C plus O2 useless to CO2 primary equation. Zn plus HCl useless to ZnCl2 and H2 also primary equation. But in the first example, the count of individual atoms are same, left side and right side. Then here left side and right side, they are different. Right? So that is called unbalanced chemical equation. I think everyone got my point. How to identify that balanced chemical equation, unbalanced chemical equation. Are you fine? Everything? Yes. Yes. Now we'll go for another topic. It is about how to balance chemical equation. So here balancing the chemical equations, the process of making the number of atoms on left side and right side is equal in number. So that process is called balanced chemical equation. The process of making the number of atoms of different elements equal on both sides of equation called balanced chemical equation. Balanced chemical equation. So here we will follow a few steps for balancing the chemical equations actually. Simple steps you can follow. It is very easy to balancing any chemical equation. What the steps are? First of all, write the chemical reaction in the form of equation called as skeletal equation or primary equation. Right? Skeletal equation or primary equation. So here, name it as primary equation. Then we will decide it maybe as a primary equation. That primary equation is a balanced or means balanced means stoichiometric equation. Unbalanced skeletal equation. Primary equation either stoichiometric or skeletal equation. Remember that point. Primary equation sometimes may be balanced or may be unbalanced. If it is unbalanced, so that first you have to verify that, counting that. So count the number of atoms, then finally you can decide the first point is primary equation is given unbalanced or balanced chemical equation. If it is unbalanced, then we'll go for the third step. First step is writing primary equation. Second step, deciding that primary equation is balanced or unbalanced equation. Third one, selecting the largest compound for balancing. Selecting the largest compound or formula unit. A group of elements is called formula unit here. Maybe ions also sometimes. Right? So that largest formula unit from the equation is balanced first. Then next, you are selected largest formula unit. Okay. in that compound also, maybe one of the atom is given with a more number of atoms. So that you can select first. Firstly, balance the element of the compound which has highest number. For example, Na2S44 is there. It is largest compound is decided. Then which is large numbered atom in that Na2SO4? O4. So O is given as 4. That we can select. Then next we'll go for balancing step by step. That balance you can solve it by using multiples or written as coefficient any suitable number. That suitable number must be smallest. Start with smallest only, as much as possible, right? To make them equal in counting, right? To make them equal in counting. Then we'll go for another steps. We'll learn how to balance the chemical equation, right? So here first we are writing the reaction. For example, here hydrochloric acid and sodium carbonate is reacted and balancing that. So the question is given, write the reaction between hydrochloric acid and sodium carbonate and balance it. Then what to do? We will follow the steps. What they are here? First step is writing the primary equation. Primary equation. You can mention as primary equation, not as skeletal equation. It may not be skeletal always, right? Sometimes may be balanced also, right? So better to mention that as writing primary equation for the given reaction. Change that skeleton as primary equation also. Then HCl plus Na2CO3 giving you what? Giving you, can anybody expect that products? Simple. Just you can make a combination of these atoms. So what I got? Na and Cl combination. What the product is? NaCl. Then here CO3 and H, they can react and give you H2O and carbon dioxide. H2O and carbon dioxide. So these are the products. So reaction written as equation now. What is step 2? Verifying that skeletal equation is balanced or unbalanced equation. So step 2 is counting that. Then make your table. Table count rows and columns. So here 1, 2, 3, 4, 5. So 5 plus 1 rows. Number of rows 5 plus 1. Number of atoms plus 1 additional titles. So you can make your table 5 plus 1, 6. Then columns are always fixed 3. One is atom name, reactant side, product side. So atom, reactants count and products count. Individual atoms count in them. Then note down the individual elements or atoms in the given table. Then what to do? So here simply we can write down H, Cl. I am following one order left to right. Then Na, C and O. So completed. No need to verify them right side. Same. Counting start from left side. So hydrogen count on LHS side. Only it is found hydrogen in HCl and subscript is 1. So count is 1. The next HCl contains 1 chlorine. Subscript is 1. Next Na2CO3. Na2. C. Nothing I repeated. C only. C1, C2, C3, not like that. So depending on your reading only, you are able to identify them. C1. O3. Completed. Not repeated themselves. If they repeated, you can combine them together. Sum. Next right side. Na. Not repeated. Na. 1. Cl. Not repeated. Cl. 1. Next. HCl. H2O. Sorry. First, hydrogen is there. H2O. Not repeated. H2. There only. 2. Next. Chlorine. NaCl. Cl. I'm not saying any number. Cl. Only 1. Next. Na. Nothing I am saying. 1. Next. Carbon. CO2. C. 1. O2. 2. Repeated. Repeated here. In H2O and CO2. So 1 plus 2 equal to 3. Here that 3 written here. Everyone got it? Everyone got it? How to make your table easily? First, repeated ones you can encircle them. To make it easy, repeated atoms you can encircle. So O repeated here. Left side nothing is repeated. So remember, only repeated will be joined together. 2 plus 1. Remaining as you are ready. So do this simple work. Okay, next table ready for us. Then next what to do? Next what to do? Selecting the largest compound. Which is largest compound? Which is largest compound? Largest compound is this one, Na2CO3. Na2CO3. Largest compound is selected. Okay. Here count of sodium is different. So you can change the count of sodium here by keeping 2 ice coefficient before NaCl. Next, count of chlorines changed here. So became 2. Left side, make it 2. Next, count of hydrogen changed here. 2. Right side, already 2 is there. Next, count of oxygens. 1 plus 2, 3 is there. Here also 3. So now it is said to be balanced one. So you can write in any order. Sir, why should I take only that, sir? You can take another. Suppose here I am solving with the chlorine atoms. Left side 1, right side 1, no need. Hydrogen 2 is there right side. So right side 2, left side 1. So 2 ice coefficient before HCl. So with that, chlorine atoms count changed. When you put 2 ice coefficient before HCl, chlorine atoms count changed. So automatically we have to balance right side chlorine count. So 2 ice coefficient before NaCl now. You can put 2 ice coefficient, okay, placed. Then count of sodium changed. Left side count of sodium is same. Then next verify. Is it balanced one or not? Balanced. Very easy steps. Everyone got it? Balancing. Verifying your table. So note down again in the table. Note down in the table again. Hydrogen left side 2 with your balanced equation. Right? So where is our balanced equation? Here is there. This one. So from this, I am writing now again the values in the table. Chlorines 2, because here coefficient is 2, not subscript. Na 2, subscript is 2. C only 1. O3 3. Then right side, any change? Yes, changed. So again observe 2 NaCl, 2 Na, 2 NaCl, 2 Cl. Individually distributive property. H2 2. Right? Next O. Everything you can same follow that as per to your table or in the same equation order. In any way you can check. Right? So any confusion in this, everyone? Give me your quick impression if you are clear. If it is doubtful, just ask me to repeat. Raise your hand if you are doubtful, or we go to quick impression if it is good. Okay, now we'll go for another example here. What is that? So simply the next topic is about balancing the chemical equation using another examples here. Using the another examples. Look at them here. So the next example here is H2 plus O2 mu is less to H2O. H2 plus O2 mu is less to H2O. So making a table depending on the count of atoms. So here hydrogen 1 atom, oxygen 1 atom. So only 2 are required. So adding 1 extra. Adding 1 extra. So what you will get number of rows here 3. So I made 3 individually. I made 3 individually. So in that I am using to write the atom name or element name. Next, number of atoms, LHS and RHS. You can make the table as given in your textbook. IST is like this also on the screen. Previously I used a reactant side, product side, but now LHS, RHS, no problem. Like this also you can make. Next, what to do? Note down the individual atoms, hydrogen, oxygen. Then here, hydrogen count 2, where it is available in H2 especially. You can give the location also to avoid your confusion from where you are observed that number of elements. The next here, oxygen count, where we observed on LHS side, especially in the O2. Next, RHS side, hydrogen count is 2, where in H2O compound. Next, count of oxygens 1 in H2O compound. So now observe that count is same. No, not same. You can copy the equation same as is again. Right? I am not explaining you steps here, directly balancing now. So count of oxygens are different, where on right side. So here you can put twice coefficient before 2H2O. 1 2 is 2. So twice coefficient before H2O. Simply use your tables. Use your tables. 1 2 is 2. So twice coefficient before. Then oxygen count is remained as same 2 2. But what about hydrogen count here? 2 2 is 4. Hydrogen count is 4. Then what to do? Make it 4 left side. Right side is 4 left side. You can put twice coefficient before H2. Now it is balanced. Then here, take one more example here. C3H8 plus O2 museless 2, CO2 plus H2O. In this reaction, balancing atom, number of atoms, next LHS side and RHS side. Then copy the individual atoms C, H, O. Any other elements? No. Then count of that LHS side C3, where in C3H8. Next, hydrogen H8, where in the same compound C3H8, not repeated. Next, O2 in O2, 2 written. Next, RHS side, count of carbons 1 in a CO2, CO2, C only 1. Next, 2 hydrogens in H2O. Then what about oxygens? 3, 2 plus 1, CO2, H2O, 2 plus 1 repeated in CO2 and H2O. That location also given. Look at them. How much it is clear. Very clear. If you find any mistake, automatically you will go that location and verify yourself. It is easy. Then balancing. For balancing, largest compound C3H8, balancing carbons. Okay. So here C3 is there. C3 is there. So you can balance carbon on right side. Put as 3 coefficient before CO2. So now C3, C3 balanced. Then the disturbance with oxygen. Count of oxygen change to 6. There is 1. So it is not possible directly. Then hydrogens also not balanced. You can balance hydrogens. Put coefficient 4 as before. Then change in the count of oxygens. 3 2 ja 6, 4 1 ja 4. So totally it became as, see here, 3 2 times and 4 nothing is means 1. So here 6, here 4, totally 10. So make it 10 on left side. So how do you make it? Already 2 is there as subscript. So use 2 table. 2, how many times 10? 5 times. So this is the method of balancing. Is it clear? Is it clear? Everyone, go to quick impression. Balancing is very, very easy. Then next one is here, balance the following chemical equations. Look at the equations here, what I am giving you. Iron oxide reaction with aluminium to produce iron and aluminium trioxide. So using a table, atom or element, reactant side, product side. Next, note them, iron, oxygen and aluminium. Then counting with their location, iron 2, where in Fe2O3, oxygens not repeated, okay, 3 available in Fe2O3. Next, aluminiums not repeated, only 1 itself. Next, right side, iron, only 1 itself. Next, oxygens not repeated and available in Al2O3 is 3. Next, aluminium 2 in Al2O3. Completed. So now tell me, is it a balanced one or not? Not balanced. Unbalanced chemical equation. So simple, to balance it, just you can round up that which are unbalanced. And look them. That unbalanced atoms available individually or combined with the other. They are available individually here. 2 there. Here you require 2. Okay. See, easy. Aluminium available independently. So 2 ice coefficient before here. Easy to balance. If you follow like this. So look at that balance. Placing 2 ice coefficient before aluminium and 2 ice coefficient before iron. So balanced now. Balanced one. Very easy to balance it. Right? So examples here. Direct balancing method. C3H8 plus O2 mu is less to CO2 plus H2O. In different ways you are able to balance. Right? So copying the same equation. So first, if you want to balance hydrogens, you can balance it. H8 is there, right side H2 is there, 2 table, 2 4 times. So you can put 4 ice coefficient before H2O, no problem. Then carbons, 3 there. Here 1 is there, 3 ice coefficient before CO2. Next, oxygens, right side you can verify. 3 2 times, 6 it is, 4 1 ja, 4 it is. So 4 plus 6, 10. So 5 ice coefficient before O2. So very easy to balance. No need to write the steps. Depending upon the marks, we can write steps. If it is asked for more 4 marks, clear explanation you need to give for each and every step. If it is asked only for 1 mark, write the table and balance it directly. If it is asked in 2 marks, write the table, write any 2 simple steps with verification. Okay, so easy way you can solve depending on the number of marks allotted for the question. So how to balance? Here I will tell you one logic. Balancing, right? So here CSO4, right side also it is same as SO4. So don't disturb that counter, right? So no need to verify that. Together you can look at SO4 is together only. So balanced. Then change in Na2, Na1. So 2 ice coefficient before NaCl. So count of chlorine changed. Count already here 2. So balanced. Then barium 1, 1. Completed. No need to check. It will be helpful in your MCQs. In MCQs, you can follow that same direct steps. Balanced. Then third example. Here H3NO3 plus potassium iodide giving you hydrogen iodide and potassium nitrate. So in this reaction, are they balanced or not? Give me your quick impression. Balanced, unbalanced. What the reaction is? Unbalanced. This is thumb balanced. What you can give? Balanced or unbalanced? Yes, P. Hasni given unbalanced. Remaining, do you agree with her? Do you agree? Shivani, agreed. Remaining else, what do you do? Only 2 are. Yes. Vedavikas also agreed. Okay. Now, here it is said to be unbalanced chemical equation. Now, how to balance it? Here, group of atoms available again. Look at here. NO3 twice. NO3 single is there. So make it twice. 2 ice coefficient before KNO3. Next, potassium count is changed. Is2. Change the potassium count. Is2 here left side. Changed. Then verify. Balanced. Completed. Group of atoms are there. Very easy. If group of atoms are there, very easy. So balancing that equation as you see here, using 2 ice coefficient before KNO3 and before Ki. The next Fourth equation, one more example. Group of atoms again available. Can anybody solve on the screen? I'll give you the chance. First one is first. Raise your hand. Who is ready to solve? Yes, Shivani raised. Now you are able to write on your screen. Just write down. First, Shivani. Divana, wait for some time. Now you can write on your mobile screen. Fast. We have only 3 minutes for this meeting time. Make it fast, please. Shivani, are you able to write on that? Once you try on the screen. You try to write on your screen. Or unmute, guide me. I'll do it. Unmute.
Sir,
Option given you. Try to write on the screen. Just you with your finger on the screen. Okay, now you are able to write. So what you are written? 3, huh?
Sir, yes, 3.
Okay, here you are written 3. Next.
PO4. Right.
Two eyes here. So you mistaken. Any other answer? Divana, you raised your hand. Divana. Now you can write on your screen. Balance it. Are you ready, Divana? Doing on the paper, I think. Okay, Veda Vikas.
Yes.
Do it on the screen, directly on your mobile screen. Okay, 2 is given as coefficient before Na3PO4. Next. No need to write the equation, man.
Sir, okay, sir.
Divana, don't write. Wait.
Okay.
Divana, stop writing. Okay, you are given 2 here. Next. Divana, wait.
Sir, 6 here.
Okay, before NaCl.
6.
Before NaCl.
6.
Yes, okay, I'll write. Okay, 6 here written. Next.
And sir, here 3.
Where?
MgCl2.
Okay, 3 is
MgCl2.
coefficient before MgCl2. Now check, is it balanced 1 or not? So simply we can put coefficient is 2 before Na3PO4. Group of atoms observed right side, PO4 2. So that's why 2 selected directly before Na3PO4. Then count of sodium is changed as 6. 6 NaCl. Next, 3 is coefficient before. So are you interested to join again? If you are interested, I will continue. Raise your hand if you are interested. Please, meeting time completed. Raise your hand. If you are interested, I will continue. I think no. Okay, we'll leave. Tomorrow we'll continue. Join tomorrow. I will give you the time tomorrow. See you.